Hello everyone, welcome to today's class. Today we will have a session on data collection, and one of our data engineers from Cosmos Research Center will present the class. So just give us 5 minutes, like give him 5 minutes to set things up. Hi Nitesh, can you hear me? Sorry for the technical problem, guys.
Hello, am I audible now?
Yes, you are audible now, but can you make
Yeah,
the
sorry.
sound a bit louder?
Yeah. Hello, is it better now?
Yes.
Let me connect my AirPods. Let me connect my AirPods. Hello, Monroe, is it better now?
Yes, it's better now, Nitesh.
Yeah, so
So I've
sorry
already
for the
introduced, so
delays.
you can,
Okay.
hello.
Yeah,
Yeah, so I've already introduced you, so you can introduce yourself as well as you can share the screen and start the presentation.
yeah, sure. So, hi everyone. My name is Nitesh Kumar. I'm currently working as a data engineer at Cosmos Research Center, and I hold masters in information systems from University of Maryland College Park, and I have 3 years of work experience in software engineering, data engineering, and analytics engineering. And yeah, welcome to the class. Today we are going to I will share my screen. Munir, should I start the recording or is it already recording?
So I've already started the recording, so it's all right.
Hmm, sounds good. Yeah, you guys can see my screen, right? Hello.
Yes,
Yes.
Nitesh.
Yeah. Okay. Should I start, Munir?
Yeah, you should go ahead.
Yeah, okay. So in today's presentation, we will be looking at the different methods of extracting the data from Rumble, Reddit, and Twitter, and how at Cosmos Research Center we have designed the data pipelines to extract the data, um, the challenges that we faced while extracting the data, and how efficient our pipelines are, and everything that goes into those pipelines. So, why data scraping for social computing? This is the question that is often we ask ourselves in the lab. So, I'll start off with what is scraping. It's a collection of publicly available web data, which is either through platform APIs or through we design the questionnaires. There are many ways of data extraction, but the most common way of extracting data is these platforms. They design the APIs and then they make it public, so we can use those APIs to extract the data. In our lab, we use the keyword driven Apify actors. So Apify is a third party platform. What it does is, on that platform, Apify itself has developed the actors that can scrape different platforms, and you can also develop your own actors and upload those actors on that platform, and then you can also start making money. So it's free for 1 week, and then after that they start charging you for whatever data you scrape using that platform. So, so the next is why it matters, why data scraping matters. So, what benefits does it give us? So we have, it fuels the network analysis, which is web as graph scale-free structures. So what is a scale-free structure? It's a scale-free if the degree of distribution follows the power law, which is most nodes have few connections, but few connections have the most number of nodes. And then we have the preferential attachment, which is the rich gets the richer. By that, what we mean is, for example, if you join a new social media platform, you're most likely to follow a celebrity that already has millions of connections. So, celebrity, you can think of celebrity or any influencer as rich who already has lots of followers. And the new person that joins the platform has the tendency to follow that person. And when you have a lot of data, you can do a lot of things. You can extract a lot of insights from the data. It enables the content analysis, which is topic modeling, sentiment analysis, misinformation in media ecosystems. It powers mashups and analytics dashboards. It supports the reproducible research. And then we have the ethical and compliance guardrails, which is respect robots, rate limits, platform policies, avoid personal identifiable information when not required. So this is about why we need data scraping for social computing. Next is, so this is a very, these days, this is a very common saying that data is the new oil. So build a refinery, which means, they say like, um, this idiom means that, like it used to be like the countries that had the oil had the influence on the whole world. They had a lot of money. So now it's data is the new oil means whoever owns the data has the more power. Think of it like that. So, there is this very famous saying by, it was said by Clive Humby in 2006. He said, data is the new oil. And then it was Michael Palmer in 2006 who also said, data is like crude. It must be refined to be useful. And in this slide, I've also mentioned the data pipelines that we have designed at the Cosmos Research Center. And this is just an overview of the pipelines that we have, which is, since in today's presentation we are looking at Rumble, Twitter, and Reddit. So we have this as a source, and for extraction we have API actors. So what we do is we scrape the metadata. So we have the keywords. For example, before starting the research, we collect the keywords for which we are going to scrape the data for, and then we give those keywords to Apify, and then Apify scrapes the data. We have different filters that we can apply that we will see in the slides that are coming ahead about the filters that we can apply. And yeah, so we have this, as I mentioned earlier, we have this keyword driven data extraction process. And next is ingestion and storage. So we use MongoDB, which is a NoSQL database, to store the metadata. Metadata is in the JSON format. And how do we refine and enrich it so that it is usable for the researchers to use that data and extract the insights from it? So we clean it, dedupe it, normalize the time zones, we fetch the media, we transcribe the videos using open source AI models. We use Whisper Open AI model, and then we add the labels. And then we make the data research ready. So we have tables, graphs, embeddings, and dashboards. So this is just an overview of the data pipelines that we have for data extraction at Cosmos. So this is the bigger picture, and this is what we follow for all the platforms. And so the thing is, I guess it's in the coming slides where I will tell you where I will take where I will tell you in detail about how do we extract the data and how the process runs in the back end. Moving on to the next slide. So this is the types of data that you can and you usually scrape, which is the first is core metadata, which is, for example, if you're scraping data from Twitter, you scrape the post ID, URL of the tweet, text, body, timestamp, language, platform. And then at the same time, so the thing is, when you're using the API factors, you do not control the data that you want because you're only giving the keywords, and the developers of the actors, they have in the back end the code that they've written for data scraping. So you know in the coming slides I will also show you the API UI so that you have an idea what I'm talking about. So we do not have control over the data that we want, but we have the control over in choosing the actors. So you can just go to the actor and see what type of data will it give you. Would it also give you the author and profile data? Would it just give you the core metadata? Would it give you the engagement metrics? So for each platform, for each uh, actor, you have different input and you get different output. But usually, it's the input is in JSON format. The output is also in the JSON format. So the only difference is in the fields in the objects, the JSON objects that we get as a response. We have content in media, so you get the thumbnails, images, video URLs, audio clips, attached files, links. You have structured entities, hashtags, mentions, URLs, domains, emojis, hashtags. No, sorry, hashtags is repeated. So you have we have conversation or context. So for example, if it's a Twitter data, we can also scrape the replies on a specific tweet, conversation ID, parent. So sometimes what the actor would do is it would just give you, so if your keyword matches with any of the replies in a tweet, it would give you that reply as the tweet, and then it would also give you the parent ID, the actual tweet under which the tweet was available as a reply. And then you have geodata and temporal data, like as I mentioned earlier, timestamp, uh, geolocation, time zone inference. We have this is the type of data that we are usually scraping. So yeah, so this is the example input API actor for Twitter. So we define what we want to scrape, keywords, filters, and limits. We have example. So here, for example, what I did was, so in the search terms, if you see here, you give the keywords, and this is not only limited to single keyword or the keywords without any spaces in them. So if I just, if I had added 10 more keywords in the search terms array, it would have what the actor would have done is for each keyword, it would have given me, so max items is the number of records that you want to fetch for each keyword. So for each keyword, it would give me 2 records, and these fields are optional, but depending on your requirement, you can. So this is what the developers have given you as an option of input, right? So you can use, for example, filter media. So there's this field filter media. If you don't want the media, you will set it as false. Filter images. If you don't want the images, if you don't want the tweets with images, so you will set it as false. So it gives you flexibility in a sense that you only scrape the data that you want. And then yeah, so we usually use 3 to 4 fields. We use search terms. For example, if we have 15 keywords for which we want to scrape the data, we would put those 15 keywords in the search terms array. So this is specifically for Twitter. I will show you on the API as well. And then we would give the max items that we want. So this is what we give to API. This is the input that we give to API, and we don't have all these fields. And then you have the query type, you want the latest data, and then you also have, see, in this input we do not have the date range, so you cannot decide, you cannot filter on the basis of date. So by default, how API factors work is they try to fetch the latest data, they try to give you the latest data first, and then they keep on going back. uh, does anyone have any questions? I'm sorry, I was just is there something in the chat? Okay, so it's one or does anyone have any question? I will pause for 1 minute, and if you have any questions, you can ask me about API or about anything.
So most of the data that you can get out of a post isn't necessarily what's actually being said in the post. Like if you're watching an Instagram post, like the words being said or the images being represented, it's like the description with the hashtags and the likes and the author and all that kind of stuff.
Sorry, can you repeat your question? Or maybe I can.
So
Yeah, go ahead.
in say you're scraping like an Instagram post and you're watching
Okay.
a video that is like 30 seconds or so, is there
Mhm.
any way to scrape all of the words being said and then analyze those as well, or is it more you're able to scrape like the likes and the engagement ratings?
Okay. Yeah, so what we do is, for example, if the video is about US elections, the Instagram video that you're watching is about US elections, or it is specifically about the president of the US, and the hashtag says, or the caption of the video says, Trump, and then we have in the input here, in the search terms, we have Trump, US elections, we have a keyword that matches with any of the textual data that is present in that post. By textual data, I think the API factors does not search in the comments, but if the keyword is in the caption or is it in the hashtag, so what it will do is it will give you the video ID. It will give you who has posted the video, when was the video posted, and a lot of other fields as well. So what you can do is, see, now this is a video. This is not just, right, like for example, I was talking about Twitter and X, where most of the data that you have is in textual format, right? So for Instagram, if it's a video, what we do is Instagram automatically does not give you an option to upload the captions. What we do is we scrape the video. After we have the video, we download the video, and then we use Whisper OpenAI models, which are used for transcribing the video. So we transcribe the video, we get the audio, so we get whatever is being said in that video, we get that in the textual format, and then we append it back to the metadata. Does it answer your question?
Yes, thank you.
Yeah. Anyone else? Or should we go ahead? None from me. Okay, good. Good. Okay, so let's. Yeah, so this is an example output. Let me go to the API. Let me show you runs. So, for example, Twitter. So this is the actor that we use for scraping the data from Twitter, right? So this is the cost of using this scraper, which is $0.25 per 1,000 tweets scraped. And this is the runs. This is the last run. So here you can see that uh, so we fetched 20 records. It cost $0.005. It started, finished, and everything. If you go here, so this is the input that I gave. This is the input that I gave to this actor. H1B, I wanted two records, query type should be latest, and then all these all these fields are set by default, and you can change them as well. And this is output that it gave me, right? So if you so these are not the all fields. This is just an overview of the output that you got. These are all the fields that it returned you. So you have type tweet, ID of the tweet, URL of the tweet. So you might have duplicate URLs as well, just different fields, because what I guess what we don't know, how do they fetch, how do they scrape the web pages in the backend. What we only know is the data that we get. So this is all the data that you get, and then you can just we refine it. We only uh, save the fields that we want, and then we only use those fields in our analysis. So for example, here you have source, retweet count, reply count, like count, code count, and you have, for example, this is the profile picture of the person who uploaded this to it. This is a cover picture, and if you come here, you have entities. Uh, this is a description, you know. So you have everything in the metadata. Usually, so if this tweet had a media in it, we would see that here, somewhere here, we would have the URL, a separate URL for the media that was part of that tweet. This URL is just for the profile picture. So this is just to show you how we use AP factors to get the metadata, right? And this is for Rumble. So you see a very very simple input. You just tell the actor the keywords for which you want the data and the limit. That's it. And then the Rumble will give you the metadata for all the videos that are on the Rumble related to those specific keywords. This is very simple for Rumble. Rumble is just a streaming platform. If you do not know about Rumble, and usually you will find the controversial topics being discussed on Rumble. Usually most of the time people are just doing live podcasts on Rumble. This is very simple. You see, I will show you the Rumble on Epify as well. So this is a Rumble Explorer. You see, run. If we go to the, so this is the last run that we have. So what was input? So the input was query was birds, limit was 100. I guess this was just used for testing purposes because we are not doing any research on the birds in the lab. So query birds, limit 100. This is the output we got. And if you just look at it in JSON format, you see this is the thumbnail. You have this URL. You have availability null. So this is not all the data that we get. This is just an overview of the data. See, these are the URLs. So we don't. So since this is a streaming platform, it does not have any textual data. It has only videos. So on Rumble, what's useful for us is if you're able to if you're able to download the videos, and then from those videos, if you're able to extract the audio, and if you're able to transcribe it, and then we get the transcription, and then we are able to do analysis on the transcription. So that is what we do on Rumble. And I also showed you the output. I guess this is dataset Reddit scraper, dataset Rumble scraper. Yeah, so this is it. And also what Rumble does is, since the videos are very long on Rumble, you have 3 to 4 hours of videos. So what Rumble does is it breaks down the videos in chunks. So you get this .mp4. This is a .mp4 file. So it was pretty straight. And the other format that Rumble provides is .m3u8. That format is used for streaming purposes. I guess that video would also be here. See this. So that .mp4 URL that was downloadable, we could download it and then transcribe it. But for this, you need some extra steps to. So this is like, you have this one long file and it's broken down into chunks. So whenever we have a video that is in .m3u8 format, what we do is we combine all those chunks, we make it one video, and then from that video we just extract the audio and then transcribe it and then append it back to the metadata. So what we do is, right, so in the final output, after we have downloaded the video and used the OpenAI open source models, what we have is a new field here, which is transcript, right? We have a new field, transcript, and you will have the transcribed audio here. This is what we do with the Rumble. This is for Reddit, and we also know that Reddit is somewhat similar to Twitter, where you will find the textual data. This is input that Epify actor takes for Reddit, and like again, so the common input that we have for all the platform, it's the keywords that you want to search, the keywords for which you want the data, and the number of for each keyword that you want, and then we have date ranges. I guess they say, see, this actor does not support the filter on the basis of that. So you will get the latest data first, and then depending on the number of items that you have here, for example, if you have 3 items, so probably if you go to Reddit by yourself, you will see, if you just type H1B, at least you will see lots of posts that are recent. So if you, instead of giving maximum items as 3, if you give it 3 million, so probably it will go back until it has collected the 3 million H1B posts. And 3 million H1B posts, I don't think so, like, people would have discussed this much in the last 6 months about H1B, so it would just keep on going back until it collects 3 million records for just H1B. Uh, yeah, so this is the Reddit output. Again, it's in the JSON format. You have the ID, we have the URL, we have the username, we have the user ID, the title of the Reddit post, the community name in which it was pasted, Shenzhen Visa, it is. Body, this community has been very helpful, and then you have the link. So you have all this data. Not all the data is useful for you, depending on the type of analysis that you want to do. You will only use those specific fields. So what we have done is, the researchers in our lab does not have access to the Epify. What we have done is we have created researcher-friendly endpoints. So we have created our own APIs, and this is the payload. So what researchers do is they have this very beautiful user interface that they use. So they give the keywords, which is, for example, if you want to do some research on artificial intelligence, on the new models, so you will give all the keywords for which you want the data. You will give the number of count. You will give the date range. So we have these 2 flags that we have added. So for example, we have Twitter, right? So Twitter, not all the tweets have the media in it. So if you want the media, you would set this flag is true, download media. So what the pipeline will do is it will it will get the metadata and give you the metadata. And in the background, since downloading, for example, in the case of Rumble, downloading 3 hours video will take a lot of time. So we don't want researchers to wait for the videos to completely download to get the metadata. So what we do is we have designed our pipelines in such a way that as soon as the metadata is fetched, it is given to researchers. It is, it's, but in the background, if the download media flag was true, then we keep on. So the media is, the media is being downloaded in the background, and whenever the download is completed, it's saved locally in your computer. We use MinIO. We have our own server, so that is where we store the data. And if you have the get transcripts field is true, so what it would do is, depending on the platform, again, I would say, if we are talking about YouTube and Rumble, we know that these are the streaming platforms. These are the platforms that have only the media data. So what it, if the get transcripts is true, in the case of Rumble, so how the pipeline works is, at first, it using the YTDLP, it looks whether the video already has the captions in it. If the video already has the captions in it, then we don't need to do the heavy lifting, which is downloading the 3 hour long video and then transcribing it by ourselves. So if the video already has the captions, we just download the captions and boom, we have the transcript, and then we can go ahead with the. So for example, if you have the 100 Rumble videos, and out of those you have, for 10 you have the captions, and for 90 you do not have the captions. So what the pipeline does is, it will, for those 10 videos, it will download the captions and store it, and for the other 90 videos, it will start the pipeline. It will start downloading those 90 videos and then start transcribing those videos. So what we do is, we do not, so the researcher has to wait until it gets all the transcripts. So this is the pain point, and this is only in the Rumble, because Rumble videos are, for example, if the video is very long, you cannot transcribe it without downloading it. We use the YTDLP, which is an open source media downloader, but we tried that, if instead of downloading the whole .mp4 file, if we can directly download the .mp3 file, it was not available. We couldn't find it in the metadata or anywhere on the platform. So we have to download the videos and then transcribe it. So this is just this slide is about what I just described. So so request hits endpoint with the payload. So this is the payload. Metadata is fetched from the chosen platform. So we also have to give the platform as an input, and if the download media is true, find media links, run parallel downloads, store in database. If get transcripts is true, check if captions available, download via YTDLP. If no captions, YTDLP downloads video, and then audio is extracted, and then the audio is passed to Whisper, and then the Whisper does the inference, and then Whisper transcribes the audio, and then when whatever transcription Whisper returns is, we append it back to the metadata, and we return the metadata to the user. So this is how this pipeline works. I will cover this slide and then I will stop for questions. So this is about transcription with Whisper. So we use OpenAI Whisper models, which are free for everyone. We use so we have multiple sizes: tiny, base, small, medium, large. You have the trade-offs. If you use small, which is faster, lighter, less accurate. So by less accurate means it's not able to transcribe the audio with 100% accuracy. The large models, they are slower, they're GPU intensive, but they have higher accuracy. What we use is, we have lots of GPU power in the lab. So we use GPUs to accelerate the transcription, and this is the parallelism strategy that we have implemented. So we use multi-threading for download tasks, which are input output bound. By input output bound means when you want, when you are reliant on an external factor. For example, you are downloading something, you are reliant on the network. If you have a good speed, it would be faster. If you do not have a good speed, it would be slower. So for those tasks, so for example, if you have to write or read from disk, you use multi-threading. For those tasks, we use multi-threading. Multiprocessing. Multiprocessing is used for transcription tasks, which are CPU or GPU bound. The tasks that require a lots of computation, that requires to use the brain. For that purpose, we use multiprocessing. And the result is we have the efficient scalable pipeline which supports high volume scraping and processing, which are also, I'm not saying those pipelines are um, that does not have errors or those pipelines does not fail, but they are, we're improving those pipelines regularly. We keep on trying new strategies and new methods to improve the speed, but yeah. So and we get the metadata with the transcripts, which is, which makes the researchers life easier. They're able to carry on the NLP, sentiment, and misinformation analysis. Yes, so I'll stop for any questions. The floor is open. If you have any questions, you can go ahead and ask. Does anyone have any questions? None from me. Okay, I guess we should continue. Thank you, guys. Thank you for replying. So, since Epify is a paid version, you know, for example, if you are working on any project, you would not want to spend your money to scrape the data. So, what are the alternatives to Epify? Epify is if you have lots of money and if you're working on a big scale project where you don't want to spend a lot of time on data scraping, then I guess you will have to go with the official platform APIs if the platform does provide the APIs. For example, for Twitter, for a long period of time, Twitter used to provide an API. Like using that API, you would pay Twitter some money and then you could scrape the data. Uh, Now they have, like reduced the number of tweets that you can scrape using their API, and they've enforced some limitations. But yeah, I mean, the first thing that you should always try is look for any open source libraries, Python packages on the GitHub, and then look for any official platform APIs. If there are any other scrapers that are available that you can use. The other thing that like that I have used and that I've seen a lot of people use is headless browser automation. So in our lab, what we do is for Facebook, for example, we did not find any good actor for Facebook. Facebook did not have any good Epify actor, so it was a problem for us. So we were trying to find a solution to scrape the data from Facebook. It was not a lot of data, so what we did was we used Selenium. Selenium is a browser automation tool. We used Selenium you know, to scrape the data from Facebook. So we automated the browser. It's like, going to the browser, entering your credentials and then logging in and then scrolling down and then, trying to scrape the data. So this is a manual kind of work. This is, but still, I mean, if you do not have any scrape, if you do not have any other solution available, it works. And also it saves money. So these are the alternate methods that you can try to scrape the data. And if they do not work, then I mean, if you can afford, then you can definitely go with the paid options. Okay, so this is the last slide, which is the key takeaways and the best practices. So the first thing is you have to be ethical and responsible. Always respect platform terms of service, anonymize data when required, and be mindful of bias and samples. So the thing is, you have to, you cannot just hit the platform with lots of requests, and you can not just scrap the data. You have to respect their policies, and if it's forbidden, I guess you should avoid it, or you should send them an email, or if you're doing it for research project. And then scrape politely, which is use rate limits. Even though if you do not use the rate limits, platforms already have this implemented in their backend. So if you are trying to hit multiple requests at the same time, they will block your IP, and then you will not be able to scrape any data. Then you will have to come up with some other alternatives to scrape the data. This is something that we experienced in our lab. YouTube blocked two of our IPs because we were hitting their servers with a lot of requests at the same time, and they detected that we are trying to do some. I mean, it was just our intentions were very clear, but still you have to comply with their policies, with their rules and regulations. So they blocked our IPs, and now we do not use those IPs to scrape any data from the YouTube. And the next is you have to scale smartly. These are very huge platforms, and there is like, I mean, I don't think so I can put it into the numbers, the amount of data that is available on these platforms. So, as I mentioned that at first we were using multi-threading for the input output bound tasks and for the CPU and GPU intensive tasks, and then you know, we realized that for transcript we can use the multiprocessing, and then for downloads we can use the multi-threading. So you have to be smart there as well, so that you can scale it, and then you can like easily scrape the data. So yeah, so this is it for today. If anybody has any questions, the floor is open, and we have research opportunities available in our lab. If you're interested, you can apply at the given link, or you can contact Professor Nitin Agarwal. Thank you so much. Yes, so Biswa is asking, can the script data be exported in format other than JSON and CSV? Biswa, we can, I guess we have the XML option available. I mean, it depends, Let me see if we have any other. I guess you can. So let me go here. This is for Rumble. So you
Yeah,
have
here
all
it
these.
shows. Yeah.
Yeah, so you have all these formats available. So you have JSON, CSV, XML, Excel, HTML table, RSS, and JSON. These are the platforms that Apify supports. These are all the formats that Apify supports. And then if you want it in any specific format, you can later on convert that to that specific format. Yeah, perfect. Thank you. Any other questions?
So if there are no other questions from the audience, I guess we can conclude the presentation today. And I'll also upload the presentation slide on Blackboard. Yeah, that's mostly it. Thank you. And by the
Okay.
way, thank you for the great presentation.
Thank you so much, Monroe. Thank you, guys. Have a good night. Bye.
Take care, everyone.